The moon. The moon revolves around the Earth once every 27.3 days. The moon also rotates on its axis once every 27.3 days. Because these periods are the same, we only ever see one side of the moon. The moon appears to rise 50 minutes later each night. All this information we have on this note sheet here, and as it says, it takes 27.3 days for the moon to revolve around the Earth, to orbit the Earth one time. So you might think that it takes 27.3 days for the moon to go from new moon back to full moon. However, that's not the case. Let's focus in on the motion of the Earth, the moon, and the position of the sun. So we have the sun, we have the Earth, and the moon. Now, the Earth is spinning, and as it's spinning, the moon is orbiting around the Earth, and the moon is spinning. You'll notice everything's spinning counterclockwise, including the Earth's orbit around the sun. So as the Earth goes around the sun, the moon is going around the Earth, and both of those are spinning. Okay, so Earth takes 365 days to revolve around the sun one time, and 24 hours to rotate once as it goes through. So there are 365 days, and each day is 24 hours long. The moon takes 27.3 days to complete one orbit, 27.3 days to rotate once. That's why we always see the same side of the moon facing the Earth. But it actually takes 29.5 days to go through a full cycle. It means to go from new moon back to new moon. I'll start off with a very simplified diagram with the sun over here, just taking up a corner of the page here, and very oversimplified, here is the pathway of the Earth's orbit. Starting off at this position, here's the Earth right here, and here's the moon. With the sun aligned in this direction right here, an observer from Earth would experience a phase of the moon that we would call the new moon phase. Their line of sight would not allow them to see any of the illuminated portion, and the moon would be in the new moon phase. So I'll just put a little NM right here. Now, during the course of the month, the Earth is going to be moving around the sun like that, and the moon is going to be orbiting the Earth. When we get to 27.3 days later, the Earth will be in a different position in space. When 27.3 days has passed, the moon will have completed actually one full cycle around the sun, one full orbit. It's returned to its spot right here in the same orientation from where that Earth is, but it's over here, and that's one full revolution. However, in order for it to go back to new moon phase, the sun and the moon and the Earth all have to line up. And to get to that position where we're back to new moon phase again, that takes additional time. The Earth will have moved, shifted over to this position. But to make things simple, I'll just keep this in mind. It takes about 2.2 extra days, giving us a total of 29.5 days to complete what we call a sidereal month. So going back to the diagram right here, if we start with the new moon right here, to get to waxing crescent phase from here to here, or 1/8 of the way around, takes about 3.7 days. To get 1/4 of the way around, taking 29.7 and dividing it more or less by 4, we get about a week or 7.4 days. To get to waxing gibbous, that takes about 11.1 days. To get to from new moon to full moon takes 14.8 days. From new moon to waxing gibbous, 18.5. Last quarter comes in at 21.9, and the waning crescent comes in at 25.6, and that brings us all the way around. Lunar phases: only the side of the moon facing the sun is illuminated, the other side is dark. When the moon revolves around the Earth, we see varying amounts of this illuminated side. This is why we see the phases. Waxing means the illuminated portion is getting bigger each night, and waning means that the illuminated portion is getting smaller. So this is the waxing portion over here. Here's the waning portion over here. Eclipses. In the introduction here, one of our introduction sheets had this laid out for us. Here we find that we can get possible eclipses when we have a new moon, and the new moon, the moon is in between the sun and the Earth, possibly can block out the sun, and the Earth gets a shadow on it. And we can get a possible lunar eclipse during a full moon where the Earth can block out the light that illuminates the moon and cause the moon to appear to darken in the nighttime sky. Now, eclipses don't always occur because the moon's orbit is tilted, and so we only get eclipses a couple times a year. A lunar eclipse occurs when the Earth passes between the Sun and the Moon, causing the Moon to become blocked out by the shadow of the Earth. Lunar eclipses occur only during the full moon phase. A solar eclipse occurs when the Moon passes directly between the Sun and the Earth, causing the Moon to be blocked by the Moon. A solar eclipse occurs when the Moon passes directly between the Sun and the Earth, causing the Sun to be blocked out by the Moon. Solar eclipses only occur during the full moon phase. Eclipses don't occur every month because the Moon's orbit is slightly tilted relative to the Earth's path around the Sun. This causes the Moon to be either above or below the Earth most months. So here we can see a diagram of the lunar eclipse. We have the Sun here. We have the Earth blocking out the Moon, blocking out the light coming from the Sun, causing the full moon to darken in the sky. And here we have a solar eclipse in which the Moon blocks out the light that strikes the Earth, creating a shadow on the Earth. Tides occur because the gravitational pull of the Moon and the Sun. There are two high tides and two low tides each day. We learned about this during our lesson on high and low tides. Spring tides occur when the Earth, Sun, and Moon are lined up, causing higher than normal tides. And we learned about spring and neap tides here. Here was a spring tide where the Moon and the Sun are either aligned on one side or the other. The pull of gravity of the Sun and the Moon work together, cause higher high tides and lower low tides. And then we have neap tides, which occur when the Moon acts on its own, causing less severe high tides. And neap tides only occur during the first and last quarter phases. And we see that here we have the moons lined up for the spring tide and in a line, but in neap tide, the Moon and Sun are lined up at 90-degree angles. So let's take a look at the moon phases that we have on the worksheet. We have the new moon, a waxing crescent, first quarter, waxing gibbous, the full moon, the waning gibbous, the last quarter, and the waning crescent. Let's take a look at the number of days into the cycle, starting with the new moon at 0. Using this chart here, we can see what the different numbers of days are going to be as we go through new moon all the way back to new moon. I've copied the numbers from this chart onto my chart down below here. For the next row, name of the lunar phase visible from Earth, I've copied the names that I wrote down at the top here into the row below, with new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, and waning crescent. Now during a new moon, 0 of the lunar surface is seen from Earth, and so we'll put a 0% in there. At waxing crescent, of the whole moon here, if we broke up the moon into a half, this would be a half of a half right here, so we're seeing a quarter or 25% of the surface lit up. Here, 50% of the surface lit up. In waxing gibbous, 75%. Full moon, 100%. Waning gibbous, 75%. Last quarter, 50%. Waning crescent, 25%. Type of tide, spring or neap. Spring tides are going to occur when the Sun and the Moon and the Earth line up. During the new moon phase and the full moon phase, we'll have spring tides. Neap tides are going to occur when either during the first quarter moon or the last quarter moon. Possible eclipse type. Lunar eclipses may occur during a full moon. Solar eclipses may occur during a new moon. Instructions. Use the diagram below to answer the following questions. The diagram shows the Earth, the Sun's rays, and the Moon at 8 different positions on its orbit. Write the number of the appropriate position next to each of the following events, and then each phase shown below. Sun rays are coming in this direction right here. Here would be our new moon phase at 1. 2 would be a waxing crescent. 3 be the first quarter. 4, waxing gibbous. 5, full moon. 6, waning gibbous. 7, last quarter. 8, waning crescent. Spring tides occur during the new and full moon phases. Neap tides occur during the first quarter and last quarter. A lunar eclipse can occur during the full moon phase. A solar eclipse can occur during the new moon phase. Looking at the phases shown below, here we would have a waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent, new moon.